Marcy and I are doing module 13 on your own, and we're starting this video with 13.2. Please read it to us, Martin.
Hydrochloric acid, HCl, is widely used as a cleaning agent in both home and industrial use. To make hydrochloric acid, chemists react hydrogen gas and chlorine gas at high temperatures. What is the delta H of this process? Is it exothermic or endothermic?
Where are you going? You don't have to. You don't have a calculator need. Come back here. Should I stop the video so that we can?
No, it's fine.
Okay. So what does it say there on the bottom of the page on the right?
Delta H is positive for endothermic reactions, and delta H is negative for exothermic reactions. Because
okay.
The delta H is the energy change in a chemical reaction. So like if it's lost energy, then it's expelling heat, making it exothermic.
So what is happening in the formation of the hydrochloric acid? Is it going to be endothermic or exothermic? Is heat being released or is heat being absorbed?
Absorbed.
Yes. So it's this kind of reaction.
Okay. How do we find the delta H?
Excuse me, it didn't ask us to find the delta
Yes, it did.
H. Oh, I'm so sorry. So yes, well, let's look at the example. How do we form this, right? What's going on? Is this the chemical equation?
We should begin by balancing our equation.
Yes. So is this the right equation for the formation? Is this a formation equation? Does this look correct to you?
Yeah, but we need to balance it.
Okay. How about chlorine? Is chlorine a homonuclear diatomic?
No.
It is.
Oh.
Should have put a 2 here. So we have H2 plus Cl2. So to balance it, what do I need on the other side?
2HCl.
Okay. Now what? What's the formula we're going to use?
The one with the example. Delta H equals
where's equation 13.6?
Energy required to break bonds minus energy released when bonds form.
So how do we find that out?
We need to look at table 13.1, bond energies. I wonder what's the energy of Casino Royale.
So funny.
But it doesn't appear to be there.
What doesn't appear to be there?
HCl.
Those two.
Oh, there it is.
There it is.
428 kilojoules per mole.
Okay, and look at the equation. Tell me about our moles. Okay. So what is our thing look like? Let's draw the Lewis structure of our molecules. What does this look like?
Yep.
Does it have any other electrons?
No.
No. How about Cl?
It's the same.
Where is Cl? Cl doesn't look like hydrogen. What are you talking about? Look at chlorine, please. Where is it in the periodic table?
It's on 7A.
7A. So what does that tell you?
It's got 7
1, 2,
dots.
3, 4, 5, 6, 7. Right? And what does the other Cl look like? You've got Cl, Cl. Is this what it looks like? Right?
Yes.
This and this. Those are our Lewis structures.
Yeah.
Okay. So now what? Why do we need to know that? Now that I can see, I'm looking on page 426 at the example. Now that I can see all the bonds involved in the chemical equation, I can look in table 13.1 and get the energy of each bond. What's the first bond you see?
C8.
How about the hydrogen-hydrogen?
Okay, 432.
How about the Cl to Cl?
That's 240
What are these again? Kilojoules?
kilojoules per mole.
Okay. And how about the HCl?
The HCl is 428 kJ/m.
Okay. And how many of them do we have? We have 2 moles,
2.
right?
So then that's more like
Okay. So look at 13.6. The energy required to break the bonds minus the energy released when the bonds form.
56 kilojoules per mole.
So if we look at the example, okay, so we have one of these, all right, 1 mole at 432 kilojoules per mole. Okay, plus 1 mole, 240 kilojoules per mole. Okay, and then we're gonna add those together, right? And then we're gonna minus 2 moles
That's 856
at 428 kilojoules per mole, right?
or 856
So.
kilojoules.
Go ahead and write them down. Let's grab something out here.
Don't chalk shame me.
No,
Don't chalk
no
shame.
intention to.
Don't chalk shame.
So this also, we just left with kilojoules, right? These moles will cancel out. So we have 672 kilojoules minus 856 kilojoules. So what does that give us?
Negative 184.
You are correct. It gives us negative 184 kilojoules. Okay. So it is not endothermic, it is exothermic. As we can figure out when we perform the calculation. How can we perform this? Only if they give us the information. We don't have the knowledge or the skill to calculate the bond strengths, right? We have to have a table given to us. Once they give it to us, we can understand how this works. So thinking of our rules of significant digits and precision, we're going to be applying rules of precision here. And so unfortunately here, we can't assume that we are precise to the tenths place here, because to the ones place, because this is a 0. And so instead of reporting to the ones place, we can only report to the tens place. We're going to say negative 180 kilojoules is actually going to be our final answer. Okay? All right, that took forever, but hopefully we had learned some things as we did it.